Just a quick show of hands. If somebody was offering this as a service for your own internal organization, how many people think they'd be interested in that? Okay, some people said they actually do it. So that's good. I saw a few hands out there. Thank you.
I know. Box up real quick.
Talk is Deral Heiland talking about web portals, gateway to information, or a hole in our perimeter defenses.
Good afternoon, everyone. As you said, my name is Deral Heiland. I'm presently employed as a senior information security analyst for a Fortune 500 company. Probably the best way to describe me is a threat vulnerability risk specialist for the corporation I work for. I have a passion for security, love sharing security with others. Believe the greatest weapons in the hand of a security professional is obviously is knowledge. So let's go ahead and get started on this. A couple quick points here. In this presentation, I'm going to be describing a vulnerability that was discovered while security testing a portal server and some of the follow-up tests that we conducted. This presentation is only the starting point. We only had limited access. We did not have access to the vulnerable server or the code directly. So at this point, there actually may be more questions than answers. So the presentation agenda, we're going to go over an outline of portal technology. This is a very high level. And some of the risks are potentially created by portal technology. And then we'll go over the initial discovery of the vulnerability, the expanded testing we conducted. And at the end, I want to go over the next phase of this project, where I want to see it go or where we're going to take it. And at the very end, we're going to go over other security methodologies that can be used to protect from this vulnerability being exploited, besides actually fixing the code. So web portal technology. Web portal technology got started in the late 90s. What a web portal is obviously it's a single point of access. It's a point where users will come to a web server and gain access to a wealth of information at this single point. A few key types of web portals, corporate enterprise, consumer-based, and personal ones. There's probably about 15 or 20 other names of web portals listed out there, but most of those are marketing terms, consumer-type stuff. So web portal technology has really grown over the last decade or so. Initially, a lot of it started out as simple web links to common information. You went to the server, it had web links to other resources, other systems, but you were linked off to those sites. What this technology has grown into is this aggregation, where you go to the site and all this information is aggregated from all these different resources and is available at that single point as if it was actually stored at that single point. And this diagram quickly shows that. A user comes in, connects to the portal server, and he can gain access to other web server systems, database systems, document management, knowledge management systems. And these systems he wouldn't directly have direct access to. The portal gives him that level of access. One of the key parts of the portal is the user interface modules. These are known as portlets, gadgets, applets, connectors. The most common term I see used is portlets. One of the standards used in development of portlets is JSR 168, Java Portlet Specification. And the purpose of this is to define a portlet API and infrastructure to make the portlet portable. Users can reuse the code. It can be moved from one server to another as long as they follow those same standards. So some of the portal security concerns. Portals are just a web server, so they suffer from all the standard web vulnerabilities. You know, SQL injection, cross-site scripting, remote file inclusion, and the list goes on and on and on. So one of the things that makes the web portal so great, in my opinion, also makes it a potential security liability. Like I said, it's this single point, a gateway to functions and services that exist on your internal network. You aggregate key data from all these different sources and make it available at this single point. So it makes this more than just a standard web service. And a lot of companies, you can gain access through their portals to document management systems, knowledge management, business intelligence, and in some cases I've actually seen portal systems that gain access to ERP systems, payroll systems, and expense reporting systems for corporations. And of course other various web content. All these sources here did not typically be accessible from the internet years ago. If you wanted to gain access, you had to be physically on the network or have a VPN connection into the internal network. Well, that's changed with the portal technology. Now we're aggregating these all at that single point, and they appear. Question?
Maybe I missed a basic assumption. You just said you had to either be connected in or on the local network. Are you including the ones that are externally available?
What I said there was, in the past, most of these sources here, you know, these ERP payroll systems, you had to be on the physical network or come in through a VPN, but that's changed with the portal technology. Now we make that stuff available to the internet directly. Of course, users may need to authenticate at that point, but now these things are exposed to the internet. In this case, I'm actually speaking in reference to externally facing portal technology, because that'd be the biggest risk. Obviously, if it's internal, the risk is a lot less. So now let's go ahead and discuss the vulnerability that we actually just discovered. We were actually security testing a web portal, and we discovered several cross-site scripting vulnerabilities. Now, these vulnerabilities weren't that unusual. One of them was actually in the news page on the site. We could replace the news story by pointing it off to another source, replace it in the user's web browser. Typical cross-site scripting problem. If you look at the URL here, I've actually changed the name of the company to Protect the Guilty. But this points off to, the news link points off to a relative piece of data that was served up the news story. If we took this news link and pointed it off to our site, we could actually replace the news story in the user's browser, a simple cross-site scripting problem. But is it? At first we documented this as a standard cross-site scripting problem. But then we went back to double check, and when I re-entered the data, I caused an error. And the server came back and said, portlet unavailable. So at that point, we start looking at this a little deeper. We wanted to know, is this vulnerability server-side? Because we know a lot of the portlets, the way they function, is they carry out transactions on the server side and deliver it up to the client, because their purpose in this case was to aggregate the data, deliver it to the client. So could this lead to deeper compromise of the system? That was our question. So the first test we wanted to do, we went ahead and we took the Acme widget news link page and we pointed it off to our website, layerdefense.com, index.html. And we went ahead and put a sniffer up on our client, and we decided to monitor the web logs on Layer Defense. Now, if this happens to be a server side, what we expect to happen would be that the client, we would see no transactions from the client to Layered Defense. We should only see transactions from the client to Acme Widget's site. And same way with the web logs. We should only see transactions from Acme Widget, is what we expected. So we went ahead and ran that. It replaced the Layered Defense, replaced the news story with our Layered Defense site. Simple as that. And of course, when we looked at the sniffer trace, it was exactly what we thought. There was no traffic from the client to Layered Defense. All sniffer traffic was between the client and Acme Widget only. And on the Layered Defense logs, all we saw was communication to Acme Widget. That's all we saw. So now we have not a cross-site scripting problem. We obviously have something else, something that appears to be server-side. So what was actually taking place from a diagram standpoint is the client would connect into Acme Widget's portal server. Acme Widget's news portlet would carry out the transaction, retrieve Layered Defense's website, bring it in there, and serve it back to the client within the known frame. So like I said, this is not a standard cross-site scripting problem. Cross-site scripting problems are a client-side attack. In this case, the client's actually doing the attacking. What this is a vulnerability on the server side, and it appears to be a vulnerability in the portlet. And what's taking place here is obviously the portlet or the portal server is actually proxying our request. So whatever website we would put in there, this portal server should retrieve it for us and display it back to us. Now I went ahead and I wrote this up originally, and I sent this off to several peers to get their input on it. And I got all kinds of interesting comments back, but one of the key comment I got back was that this had similar aspects to a cross-site request forgery. But in the case of a cross-site request forgery, the attack is exploiting the trust of the actual client. In this case, the client's the attacker. There's no concern of the trust of the client. But what we are utilizing is the trust of the server. So we bantered this back and forth in probably several hours of debate, and the conclusion we came away with was this is more of a server-side request forgery. And that's kind of our 2 cents worth coming out of that little bit of conversation we had with some friends, so you can take that for whatever it's worth. So now that we know that this is a server-side vulnerability within the web portal and its portlet, what else can we do with it? One of the things we wanted to see is, can we gain access to internal resources using this in this particular case? Can we gain access to printers, switches, internet web systems, routers, management consoles, and maybe even firewalls? Now in this day and time, it seems like everything's going the way of the web interface. All of our firewalls, our routers, our switches, all of our devices are being web enabled. I think almost everything in our environment has a web interface for it. A lot of key systems do. So the first test we wanted to do was see if we can gain access. And a lot of this plays on the part of the actual infrastructure security also, besides problems with the portal. So the first test we wanted to do, and this link right here, is setting on the internet, we wanted to point to an internal IP address and see if we can make an attachment. So we pointed it to an HP printer. This happens to be the TCP configuration page for an HP printer. So we went ahead and ran this from the internet, and we brought up the web page for the HP printer. Now, if we tried to actually use any of these links in here, they would all fail because they're either relative to the portal server or they're relative to the 192.168. In either case, they wouldn't work. So at this point, how could we actually make alterations to a printer if we wanted to, or alterations to another web server? Well, we know anytime you want to post data in a cross-site scripting problem, you pass the data in a GET. So same thing here. So we went ahead on this second line here. We decided as a test subject, we'd point to that same printer. And the goal was, let's see if we can get it to print out its configuration page. Now, we did have physical access to the internal network. So we went ahead and ran this, and it did work. It printed out our configuration page on the printer so we could actually pass data to it in the GET, pass post data to it. And it also replied back to us with a response page through the portal saying that the print job had completed. So functions and limitations. While we were doing all this testing, there's several things we noticed, and I want to bring those out here. We could access web resources on any TCP port. It wasn't just 80. We noticed that we could actually point to, as an example, we pointed to Tivoli endpoint, a port 9495 that was running on client machines on the internal network. We also were able to point to an Insight Manager on 2301 on several servers and bring up the web interfaces on those devices. The one thing we couldn't get it to work is the SSL would not work. Not quite totally sure, other than apparently the portlet wasn't written to handle SSL transactions. And until we get the code, we won't be able to positively identify yes or no or why. The one thing we did notice is we need to point to a file name. If we pointed to the root of the server, it would not give us any response back, or appeared not to give us any response back. So we had to specify a page, like HTML, like index or default HTML or some other file. The other thing we noticed was that all the data came back to us in raw information. Obviously, if we pointed it to a web page, our browser is going to render that. If we pointed to a Java, our browser is going to render that. But if we pointed it to a GIF or a JPEG, the results were pure raw. It would actually dump back the raw binary data to us. This happens to be the banner JPEG for the logon page on an Alcatel router. And this was connected to from the outside. So now that we were able to do this, we can get access to the internal network. We can actually post data back to these web systems. One of the other things we wanted to do was, can we use this to recon the internal network? As I said, so many systems are becoming web-enabled now. So why can't we use this to recon? So the test we decided to put together was, we pointed it to a IP range that we knew had a lot of targets. And we went ahead and used the / index.html because we had to point to a specific name. And we were able to attach to Alcatel switches, routers, and at least identify these things. A Juniper NetScreen firewall. We were able to connect to HP integrated lights out and a via PBX system. We're also able to connect to a VoIP system, management console. The interesting thing on the VoIP system, I don't have the name of it up here. I can't remember what it was. But it was totally unsecured, so we had the ability to alter anything we wanted to on that VoIP system. And of course, we found all kinds of standard web servers running in this environment that probably the company really didn't know at that time had been enabled or turned on. Now, like I said, we had to actually point to specific files, index.html, default.html. But we also realized that if you knew you had a specific target that you were looking for, that you could recon a network for it. And examples we use here is we were able to connect to all these different printers here, copiers, fax machines. We connected HP, the Ryko, Sharps, Lexmark printers. Managed UPS systems, the uninterruptible power supplies that a lot of the servers were running on at different locations. We could connect to those. If they weren't secure, we could take control of them and shut them down. And we also were able to connect to the management console of our SAN system, which was kind of fascinating. One of the things we had tested, but we did not test it external to the company. We did it internally to it. Back when we were doing the HP printer, as a test, these were production equipment, so we couldn't really bring anything down. So one of the interesting things we wanted to do, like I said, we had tested the HP printer printing out a page. And we did all this from the internet. But internally on the network, and I'm positive it will work externally, we actually modified an HP 9000, I think 9050 printer that has the ability to set it up to take commands through email. So it would go out to an email server and get those commands. We actually set the printer up using this to retrieve email from one of our layered defense sites, and could actually control the printer remotely that way as a test. So we could also use this vulnerability to proxy attacks to external targets and make it look like it's coming from this company's portal system. So as we wind down here, some things we want to go over here is the next phase of this project. We want to determine whether this vulnerability is an isolated occurrence or has more common. Now, I realize this thing is not as common as a cross-site scripting problem, but I also believe it's more common than this single occurrence that we discovered. And from a personal standpoint, I want to get in a deeper dive into the portlet coding standards, and hopefully we're going to get our hands on the specific code that was associated with it. I've been trying to do that for a couple months now, and I figure here soon I'm going to get my hands on that, so that we can start looking at that and seeing why it was written this way, what's wrong with it, and maybe use that as a comparison as we go forward in some of our testing. We also want to lab up and do some testing of portals, other portal products besides the one we found this in, and look at other portlets. And of course, the big thing here is I want to get other experts involved. There's a lot of talented people out there that have a lot of experience dealing with Java coding, more so than I do, experience dealing with portals and portlets. So it's important that I can get some of them involved in this, so potentially we can move this project forward and see if this problem is more widespread, because this is really major if you think about it. So, quick final notes. This simple vulnerability that we discovered here that looked like a cross-site scripting problem in the portlet We were able to compromise the parameter security of a major corporation. We were able to exploit internal web systems by sending post data in and altering configurations. It may have only been a printer, but we could have easily targeted the VoIP system or various other resources they had on their internal network. We were able, at a minimum, to recon a small segment of the network. Now, I expect this recon process would be fairly slow because every bit of this was ending up in their logs, but very doable. Slowly recon an entire network of a corporation, mapping out their infrastructure and identifying hardware on their systems based on the web interfaces. Of course, basic testing, we could verify we could carry out proxy attacks to external systems. And one of the things we really didn't test was actually server-side attacks. We could have easily taken this and carried out a server-side attack on that system. As I mentioned earlier in the presentation, that web portals have all these different things available, ERP systems, payroll systems. Now, your access to any one of those, the actual portlets that may be driving those, may be restricted and you have to authenticate. But if we could carry out a local attack using a server-side problem with one of the portlets, could we gain access to other portlets, gaining access to other resources on the internal network? Now, the obvious. Implementing other security methods is advised. If these things had been done here, if they had been implemented, I would have probably passed over this vulnerability as a cross-site scripting problem. It would have been logged as that, because that's what it appeared to be. Yeah.
Given the access that the portal server has, just for argument's sake, why does it make a difference having it in the DMZ? It's going to be able to establish inbound connections anyways. Why should that make a difference?
Well, in the case of our actual exploit, you're right. You can gain access to those resources that are authorized, but you couldn't recon a network. In our case, we could actually recon the entire network looking for web interfaces. Here, you would have to figure out what the established connections are. Now, you may have to try reconning the entire network to identify that, or attack I assume attack the portal server locally to identify those connections through the inside firewall in the DMZ. Yeah. Yes. Yeah. Yeah, correct. This here is meant to be other than the actual fix in the code. Now, truthfully, how was our environment here protected? This was actually protected with a layer 7 firewall was put in place. Various resources identified here were done, and a web firewall was put in place, or a layer 7 firewall was put in place to restrict this. And then the code was fixed also. So multiple things can be done. But some of the basics, not all companies are going to implement layer 7 firewalls. So they're very pricey to implement those in some cases there. And the whole idea of this stuff listed right here is purely meant to say, beyond fixing the code, because you have to identify there's bad code. If this stuff had been done here, I think in spite of the code being bad, it would have restricted the access to some civilized level. Any other questions? Right.
Was this a COTS product, or is this a one-off in-house thing? And if it's a COTS product, have they fixed it?
No, this was not a in-house product. So I have obscured some of this because I haven't got my hands on the code that's part of this. I've restricted some of this information here because I don't want to come in and say, hey, here's the vendor of this, because this could have easily been one of the built-in portlets. And I haven't been able to get my hands on that code to verify that yet. Once I've done that and verified, hey, this portlet was built in-house and our people screwed up, or was this portlet part of the built-in package that was delivered by the vendor product? Haven't been able to make that determination yet. So I've restricted some of the URLs up there so that it doesn't obviously say, hey, this is the product. Yeah.
Did the web group actually know that it's like, gee, this is bad? Did they notice anything from all of the stuff that you injected into their logs?
No, they never bothered looking at the logs.
Okay.
They never bothered looking at the logs, and when I told them about this, they looked at me like I was crazy. So what's the problem, Daryl? I don't know. What do you want me to do to your network? And then maybe you can tell me what the problem is. And that's where, as the gentleman over here mentioned, one of the solutions is a Layer 7 firewall. In this case here, that was one of the things that were put in place, besides fixing the code, to actually restrict this.
I lost the mic, but you don't need a Layer 7. You can get rid of your problem here with being able, all you need is a Layer 3, IP filter or checkpoint or fix it. Here are the IPs you can go.
Yeah, there is no one solution to this problem. It's fix the code, do this stuff here. Layer 7 firewall is an expensive solution, but it is a viable solution. And if you put all three of them in place and you do things right with the architecture, the coding, and the firewalling, these problems go away.
If you run out of money, 80% into the project.
Yeah, that's probably true.
I actually just have two observations, comments. One, you left out something rather important, is that to carry out this attack, you're going to have to be able to successfully authenticate into whatever portal system you're dealing with. And number two, if you have a portal system in place in your network that, this goes back to the DMZ conversation, that, can log into your routers on port 80 or whatnot, you really need to fire your security guy because he's doing a really shitty job.
Interesting enough, this was actually the news page. Being that it's the news page, it was generally accessible. So at this point, there was no authentication on this one. That should make it all that much more scarier, and we should fire them all. I agree, but they won't listen to me. Any other questions? That's on the part where we said we did not try attacking the server side, but obviously that would work. If there is something, a web interface, a management console, or something that's local, you could potentially gain access to it. The other thing is looking at like port 8000 or port 8081. There's a lot of these management consoles that are sitting right on those servers too, that you can actually gain access back into the internal server, or at least bring up the web interface. Whether you could gain access is all come down to how well they have secured it. Yes?
When you were doing these attacks, you just changed the get variable. Did you do any kind of programming and try to, post information to see if that would change anything?
Well, in this case here, we just passed it through the get, which was the redirect on the news page. We just put it in there. That was the only thing we did. We didn't try to pass anything serious through. Because remember, I'm in a production environment, and if I bring a bunch of stuff down, they fire me. Right. Right. In this environment, no, we did not. All we did was try posting the data through a get. That's all we did. Well, thank you very much. If anyone has any questions outside of, here's my email address. Yes.
Is there anything you want me to do for an introduction for you?
No, that's, I mean,
Okay. Isaac Mathis?
Isaac Mathis.
Okay.
Maybe tell everyone I flew in all the way from Japan just to be with them.
I'm